Hey guys, today we're going to talk about having primary, secondary, and tertiary degrees of substitution. We have this type of substitution whenever we have a hydrocarbon change that has a functional group attached to it. An easy way to identify them is the pencil method. Determining the degree of substitution will come in handy whenever you have things such as alcohols, halogens, and other functional groups. For example, let's say we have a butane that is attached to a random functional group. The first thing we should do to determine the degree of substitution of the carbon is identifying the carbon to which the functional group is attached to. Then, we're going to place a pencil on top of it and draw lines to the carbons next to that carbon. In this case, we have two. It's important to know that we are not going to draw a line up because that line is not attached to a carbon but to a functional group. Another important thing is that when you have a methane, you won't have a degree of substitution. Because if you were to put a pencil on top of that carbon, you will only have hydrogens attached to it and no carbons. Now, to determine the degree of substitution, let's see some examples. For this example, we're only going to see alcohol. In the first one, we have ethanol. Once we put the pencil on top of that carbon that is attached to ethanol, we can only draw one line to the nearest carbon. This makes it a primary alcohol. Now, for isopropyl alcohol, once we place our pencil on top of the carbon, we can only draw two lines connecting to other carbons. This makes it a secondary alcohol. Lastly, terbutanol has three lines connecting to different carbons, making it a tertiary alcohol. Another important thing to note is that we won't have a quaternary degree of substitution. Remember, carbon likes to make 4 bonds, so when we add an extra carbon to a tertiary alcohol, we are breaking the octet rule. So we won't see this type of carbons. This is it, guys. I hope you find it helpful, and if you have any other questions, ask your peer leader.